Okay, so now that we've talked about what the natural log is, now we'll talk about its derivative. So if we have something in the form, well, actually, let's make this easier. So if I just wanted to straight up take the derivative of the natural log of x, that's just going to equal 1 over x. Just that simple. Whatever's in these parentheses, it's 1 over x. If we're going to get a little bit more complicated, where we have like the natural log of something fancier than x, natural log of like x squared or x cubed, something like that, then it's going to be 1 divided by whatever the function is that's in the parentheses, and then times the derivative of what's inside. So this is basically the chain rule where we're incorporating what we know here. So number 1 says, use the chain rule to show that if a of x equals e to the natural log of x, then a prime of x equals 1. Okay, so let's see how this is going to go. So I want to use the chain rule. The chain rule says that we would do, chain rule says f of g of x, if I'm taking the derivative, that's f prime of g of x times the derivative of the inside. So I have an outside function, which is e to the x. Oh, let's make that cleaner. So my outside function is e to the x, and my inside function is natural log of x. So the derivative of the outside is just e to the x because it's the identity. The derivative of the inside, like we talked about over here, is just 1 over x. So using my chain rule, the derivative of the outside is e to the x. So e to the x, where I plug in the inside function, e to the natural log of x, times the derivative of the inside function, which is 1 over x. We know e to the natural log of x cancels to just be x, so I have x times 1 over x. X's will cancel, and I just get 1. Okay, number 2. Differentiate the following. Don't forget to use the derivative rules, chain rule, power rule, product rule, and quotient rule. Okay, so part A, to me this looks like a chain rule where the outside function is 4x to the 6th, and the inside function looks like natural log of x. So the derivative of the outside function, 4 times 6 is 24. 24x to the 5th. Derivative of I, we just learned this, is 1 over x. So I want the derivative of the outside. Oh, don't need to write that. Derivative of the outside, which is 24, whatever's in the parentheses, to the 5th. And then I'm supposed to plug in the inside function, natural log of x. And then I would multiply by the derivative of the inside, which is 1 over x. Okay, so part B is a product because there's a multiplication symbol right there. So I have a first function, which is 4x to the 4th. And then I have a second function, which is just natural log of x. So the derivative of the first is 16x cubed. Derivative of the second is just 1 over x. This is a new thing that we're learning. So I could do the first times the derivative of the second plus the second times the derivative of the first. 4x to the 4th times 1 over x plus natural log of x times 16x cubed. Okay, so let's move on over to part C. So this also looks like a product rule. There's a little multiplication right there. So my first function is 2x cubed plus 4. Second function is the natural log of x squared. Okay, derivative of the first is 2 times 3 is 6x squared. Derivative of 4 is 0. So then the derivative of the second function, this one is actually a little bit more complicated because it's not just natural log of x, it's natural log of x squared. So we'll actually have to use the chain rule over here. So we'll come back to that. So for this one, the outside function is the natural log of x, and the inside function is x squared. Derivative of the outside function is 1 over x, and derivative of the inside function is 2x. Okay, so I'm still trying to find the derivative of s of x, but now it shouldn't be too bad. So s prime of x is going to be the derivative of the outside with the inside plugged back in, and then times the derivative of the inside, which I might as well clean that up because 2x over x squared, the x's are going to cancel, so I have 2 over x. Okay, so then I need to go back and finish and do my product rule, which says you could do the first times the derivative of this, oops, battery's running low, first times the derivative of the second plus the second times the derivative of the first. So that would be 2x cubed plus 4 times 2 over x plus the natural log of x squared times 6x squared. Okay, and I'm going to stop there because my battery's dying.